Now we also want to be able to factor polynomials using a grouping method. And so we have, in this instance, this is example 3a, we're asked to factor out the common binomial factor. So we really have two terms here, and I can see that, you can see that I've underlined each of those two terms. And when we look at those two terms, and by the way, just for clarification, that first term is a term by itself because the a squared and the b plus 1 are multiplied together. Terms are separated by addition and subtraction, so that multiplication makes them be one term. So when I look at the first term, a squared times the quantity b plus 1, and the second term, t2 times the quantity b plus 1, I notice that what they have in common is the b plus 1. So that is what we call our greatest common factor. It is a binomial factor. So if we divide the first term by b plus 1, then the b plus 1 will cancel. If we divide the second term by b plus 1, then the b plus 1 will cancel. What we have left over is a squared plus 2. So a squared plus 2 is our other factor. So another question that involves factoring by grouping is this one, which is example 4 in our PowerPoint. This one, though, we start with just a polynomial that has 4 terms. Now, just a note, if you are factoring a polynomial that has an even number of terms, it's very likely that you're going to be able to factor this using the grouping method. So if I just take and I group the first two terms together, the x squared and the 2x, and then group the last two terms together, the negative 3x and the negative 6, I want to factor each of those groups separately. So first of all, when I look at the x squared and the 2x, I notice that they have an x in common. So x is my greatest common factor. If I divide each of them by x, x squared divided by x is x to the 2 minus 1, and 2x divided by x is just 2. The x's cancel. The second group, notice, begins with a negative number. In that instance, you want to pull that negative sign out with your greatest common factor. And when I look at the negative 3x and the negative 6, I also notice that they're both divisible by 3. So my GCF is negative 3 here. So I'm going to divide everything in that second group by negative 3. Well, negative 3x divided by negative 3, those negative 3's will cancel, and I'll be left with just x. Negative 6 divided by negative 3 will be positive 2. So now notice our first term and our second term have something in common, and that is x plus 2. If I factor out the x plus 2, the x plus 2's will cancel. And what I'll have left is just that x minus 3. I have factored this polynomial with an even number of terms down to 2 binomials using the grouping method.